Howdy, it's tubalcain again, and this time with machine shop tips number 289 entitled Cutting a Straight Keyseat on the Logan lathe using the Palmgren milling attachment. Be sure and go back and watch number 288 as well, where I show how to cut a Woodruff keyseat like that. And there are some things that apply to this that also apply to these square keys that I'm going to cut in this one, and I won't repeat some of that, so one video kind of depends upon another. Now what we're going to cut is a straight key seat. These are straight keys. Sometimes they're called parallel keys. Sometimes they aren't square, but in fact might be rectangular, especially in the larger sizes. You know, for real big shafts, 2, 3, 4, 6-inch shafts, whatever, they probably will be rectangular. And these can be bought at any hardware store right alongside the Woodruff keys. And more than likely you're going to go and buy it in key stock like this, called Make a Key and other names, and then you just cut your key to length. Now, what are the advantages or disadvantages of using Woodruff keys over straight keys? Well, I suppose there's a lot more than what I know about, but for one thing, a Woodruff key cannot escape from the slot if this is tightened. It just can't get out of there. And matter of fact, you can barely see the key from here. So that's one advantage. And I have noticed over the years in repairing things that sometimes a straight key like this will work its way out. And in fact, if the device isn't guarded or protected, this can get caught in your cuff or your clothing, or a rag or something like that can catch onto it. So, and there's a longer engagement with this type of key than there is with this type. So if you've got a double pulley that is perhaps 4 inches thick, you can have a key that is 4 inches thick. I have, however, seen 2 of these in a row on devices to increase the length. These are usually hardened and these are usually soft in my experience. So that's the difference between half moon Woodruff keys and parallel or straight keys. And today's subject is strictly straight keys. Now, what kind of cutter do we use? You can use, and I'm going to show 2 different ways. I'm going to show how to do it with an end mill. This is a 3/16 end mill, because I'm going to cut a 3/16 key seat. But you can also use, by the other method, any of the Woodruff key seat cutters that are 3/16 thick. And even though we have different diameters here, there will be more than one that is the right thickness. In fact, I prefer that method over an end mill, because it's harder to cut it straight with this, because the end mill does deflect, or can deflect. So let's go over to the Logan lathe and get started. But I guess before we step over to the other side of the shop, we need to talk just a little bit about the mathematical calculations. And first, the depth of the key seat, and in this case it's a 3/16 square. So the way that I found that is that a half of 3/16 is 93 thousandths, and then we need to add the chordal depth, and I've talked a lot about that, and that can be found in Machinery's Handbook, both in a chart, or you can calculate it according to formulas, and they give you several formulas there. Now, I know a lot of people don't cover this, but and they just mill a little deeper than half the thickness, and in fact that's probably going to work most of the time, but there are specifications for this, and your drawing may or may not include that, and sometimes you need to do the calculation as a machinist on the shop floor. So anyway, the total depth here, adding the two, is 108 thousandths deep. So do your calculating before you start cutting. And then the other one is we have to find the center of the shaft with our tool after we touch off, and that's done by finding the radius of the shaft, and it's 5/8 stock, so half of that is 5/16, which equals 0.3125, and then half the thickness of the cutter. This is a 3/16 cutter. half of that, or the radius of that, is around 93 thousandths. Add the two together, and the center of the shaft after touch off is 406 thousandths and change. I'm over at the Logan lathe, and I'm on the back side, and that's one of the disadvantages of using a milling attachment on a lathe, is that you're looking over the attachment. It's kind of hard to see what you're doing. But anyway, the attachment was set up in a previous video, and I showed you how to do that and how to square it and how it should be clamped down and mounted and all of that. And in fact, everything is in virtually the same position as the last video. So I'm not even going to show how to center it this way. That's the longitudinal way, because that was already found in the last video. And remember, that's the amount once I touched off on the side was 406 thousandths. And now I'm ready for the depth. And I know I'm rushing through this part quickly, but I'm going to go into more detail when I use the end mill. But the depth again is 108 thousandths, and I am going to touch off now. I put some tape on here, and that was shown on the other one also, but I'm going to feed down until it just touches and tears the tape. And I'm just turning the belt by hand now. Alright, you see it's touching the tape. Now I'm going to swing around to the other side and show you how I'm going to feed depth-wise, 108 thousandths. I'm back on the front side of the Logan. And take care to lock your carriage in the Z-axis, because we have centered the cutter on the work, and in fact this is all set and locked from the previous video. Now for the depth of cut, normally as in the last video I have been feeding and reading the little graduated dial here, but that's rather hard to do, and I'm just showing you an alternate way of doing it and probably more accurate. But I have a dial indicator touching the vise here, and it's got a magnetic base that is affixed to the cross slide back here, and I'm making sure that the gib lock is loosened and that I have enough travel here. This is zeroed out, so it's 108 thousandths. And when you do this, make sure that you backed your cutter out so it's not going to crash on the work, on the shaft. Then I will lock this real well, and I'm ready to cut. I removed the dial indicator to get it out of the way, and I slowed the speed down so it's about 600 RPM, because I get accused of running the machines too fast. And what I said here, or I may have not have said it in regards to backlash, because I will be climb milling, which is in that direction, meaning that the cutter is trying to climb up over the work and can pull the backlash out of the cross slide, the lost motion. And when that happens, you can break the cutter off, or you can chip a tooth, or whatever, but it's just not a good thing. And by the way, my cutter is held in a 1/2-inch collet, as in the previous one, and this is a 3/16 wide Woodruff Keyseat cutter. I don't know if I mentioned it or not, that if you're cutting tool steel or real tough material, or you have a small machine or a dull cutter, you may want to make this in more than one pass. Now I need to avoid sticking my hand in here with the brush, because that throws the focus off. I did snug up that gib just a little bit in the x-axis, hoping that that would help. There I go. Don't stick your finger in there and wait till the cutter stops. Make sure your glasses are on. And I'm going to back off, deburr it just a little bit, and if possible, attempt to put the pulley on with the key in place. Now remember that at the end of the key seat there'll be a radius produced by the cutter, so sometimes you do well to go a little bit past your line so you don't have to deal with that. I've taken a few moments to clean it and remove the burrs with a little file, and I've got a pretty good fit here with the square key, and I have barely enough room to insert the pulley. Here's the acid test. I've got my pulley mounted on the shaft, the square key in the key seat, got a good fit. Now there is a dimension for this too, that and some of you I know aren't interested in any of the math, but if you are, there is a dimension in the book for this after you've cut the key. So I've got the calipers across both the shaft and the key, and you can see that I'm 709.5, really is 710 or rounded. Well, could be either way rounded. But looking in Machinery's handbook now, and I've marked the page. That paper go flying all over, and that's this dimension here, which they call T. And down on the line here, which is for a 5/8 shaft, you can see that dimension needs to be 709, and I'm really surprised that I'm that close, but I guess I am. So that's what a straight key seat looks like. That's how to do it with the Palmgren attachment. You can see I got a little chatter there, but it didn't make one bit of difference. And this is the radius that I'm talking about at the end here of the key seat that you have to deal with, so you need to make it just a little bit longer. And you can see I went a little bit past my black mark to try to overcome that. Now I'm going to show you how to do it again with an end mill, and I'll be milling on the side. Similar setup, but some differences. I'm back for the second part of the video, and in this part I'm going to cut another key seat in the 5/8 stock, but by a slightly different method, this time using an end mill instead of the Woodruff cutter. So let's take a look at how I'm going to do this. Many of the operations here will be exactly the same, but yet there's some differences too. Now notice how I've held the stock in the vise. Again, I'm in the little V-way here, and I'll be milling in this section here about 1 inch long, but note that I have a little bit of material sticking out here, and the reason for that is that I need to be able to touch off in order to find the center of the work this way. So I'll be touching off in 2 directions and be using the same dimensions for depth of cut and offset as I used in the other one, because the cutter size is the same and the shaft size is the same. From this side of the machine, you will see that I'm holding the 3/16 end mill in an end mill holder, not in a collet like I did with the Woodruff cutter. And of course, this could be held in a collet. I'm just showing you another way of doing it, but when you hold it in an end mill holder, the set screw presses up against and locks the end mill in, so it cannot spin. And this one is a 1/2 inch diameter, but I've used a little adapter here, a sleeve that came in the set with the Atlas. This is an Atlas product, and it's a number 3 Morse taper that's held directly in the spindle and pulled in with a drawbar, which you can't see, that sticks out of the far side of the headstock. And also I put a thread protector on here. So now I'm ready to touch off on the top so that I can find the center of the material like I did in the previous method. I will now touch off, and this can be done with the machine running, or it can be done just by pulling on the belt like I'm doing now. And you can use tape on there or a piece of paper, or simply just scratch the work, and that's going to be close enough, let's face it. Alright, here we go. And I am raising the work, and you can see I peeled the tape right away. And now I'll back the carriage out of the way. I have to unlock it. And I can now raise the work. Do you remember the math from the previous one? We need to go up the radius of the shaft and half the thickness of the cutter for a total of 406 thousandths. Notice that I have a Mitutoyo plunger type indicator right on the work, and it's held here with a little stirred magnetic base. I've zeroed it out, and I've got plenty of travel right here, and we're going to raise the entire fixture here 406 thousandths. 100, 200, 300, 400 and 6 thousandths, and I'm now on the center line of the 5/8 shaft. And I will now lock the gib right here. A couple of other things I want to show you while I'm on this side of the machine. I forgot to tell you that this type of end mill holder will not accommodate a double-ended end mill like this. That is a single-ended one, because that is a blind hole in there. Now, regarding the length of the key seat that I'm going to cut, you can have a layout line on there, or you could use an indicator for that matter too, but I've got a stop installed here. It's really a thread stop, so that I can just cut until I hit the stop. I don't even have to watch the length, and you'll see here that at some point when I come in all the way that the cross slide here is going to hit this stop, the bolt that's on the stop. And I did have to remove this chip guard in order to install that. I don't really like taking that off, but there aren't a whole lot of chips produced that would get down into the screw, so I'll be okay. Or you could cover this with paper or tape or something to keep the chips out. Next, I'm going to touch off in the Z-axis. Now, you can do this with or without the cutter running, or with or without paper, and I believe it's going to be accurate enough this way. I'm going to put the flutes in that direction. I'm just going to come up and touch. And I'm going to temporarily lock the carriage, and I'm going to back the tool away from the work, and now I will set the depth of cut. Again, there's several ways to do this, and in the last video I had locked the carriage and I did the feeding with the compound, and I watched the graduated dial here for the depth. But I'm going to show you a different way, and that is to use an indicator, and that's on a Mighty Mag base right on the bed, and the tip of the indicator is up against the cross slide. Be careful you don't get it in one of the gib holes, and I've zeroed this out. Now, I've determined that the depth of the cut we talked about before is 108 thousandths. I do not want to do that all in one pass, because as I've told you, these real skinny end mills do tend to deflect, and it's hard to get a straight keyway or a straight slot. So, and this is really a slotting operation. Using the Palmgren here is really just something that is rather makeshift compared to a milling machine. So I want to take it in 2 or 3 cuts. I will start by just taking a 50 thousandth cut, and watch the indicator. So I'm moving it in 50 thousandths, locking the carriage, and now I am at long last ready to cut, and all this would go very fast if I wasn't talking about it. I'm ready to start cutting. Put a little Earl on there. Remember, it's only 50 thousandths at this time, and I'm just going to come up against the stop, and I won't show the whole thing. Now, if you don't have a stop, you can just watch your graduated dial on the cross slide. Could you use a power feed for this? I suppose, but I'm just feeding by hand. I'm feeding relatively slowly. It's a nice sharp end mill. 1018 steel. And I'm just finishing the first pass, coming up against my stop. That's it, I'll back it out. And I'm going to take another 50 thousandths off. And I'm not going to show that, and then I'm going to take a final 8 thousandths off. In other words, I'm taking it in 3 passes. And this is the third and final finishing pass, just taking off 8 thousandths, and this should complete it. You can see I'm not taking off much. And if you get a lot of vibration, take 8 passes, 10 passes, whatever it takes, because there's just a lot of shaking with this Palmgren attachment, because there's so much overhang, which I showed you in one of the videos, and that's, of course, one of its downfalls. You never have the rigidity that we have in a Bridgeport mill. This is easy cutting now, and there is a little bit of oil on it. And I actually am watching this as I cut in my video monitor, which is greatly magnified and far easier for me to watch than the actual cutting tool itself. Oh, the miracles of modern technology. Modern, there's nothing modern about this. This is strictly buggy whip making. And I will just feel that come up against the stock. And of course, using an end mill leaves a radius on the end, as you can see. And now I'll take it out, and I think you can see, I'm going to wiggle. I am wiggling with my hand the top of the Palmgren milling attachment, and you can see how much play there is in the thing. Watch it now. Are you able to see that? So that lack of rigidity is what's causing the chatter and the poor cut. All right, out it comes. Actually, before I remove it from the attachment here, I put a key in the key slot, and I'm checking it with the calipers now, and remember that the dimension there should be about 709, but remember there's a tolerance. And I am getting a reading here of about 705, and that's close enough. Do not take this out of the fixture until you're sure that it's right, because you would never get it back in if you had to take off just a little bit more. But now I truly will take it out and deburr it. And you can see there's a lot of burrs. But not too bad. Over to the bench. There it is, deburred. And there wasn't as much burr on there as I thought there would be. And the key fits into the key slot. Like that. It's a good fit. And let's put it on the pulley. And it's ready to be set down with the set screw. So there you have it. That pretty much completes this video on how to use the Palmgren milling attachment on the Logan lathe to cut a keyway by 2 methods, with an end mill, and then where's the other one, with the Woodruff Keyseat cutter. Both for parallel type straight keys. One other thing I didn't show you, not that you'll care, but that chordal depth that I looked up in a table in the Machiner's Handbook can also be done mathematically, and there's one of the formulas, but you know, you got square roots and all kinds of stuff to deal with, and a lot of you guys that are rusty on your math aren't interested in that. But hope you liked the video. It ran a little longer than I thought it would. Be sure and watch all of my other videos, and thanks for watching. This is tubalcain saying so long for now, and I'll see you in my next video.